So remember, percent is divide by 100. So whenever we see that symbol, we can alternatively replace it with dividing by 100. And we often calculate with percents. Like sometimes I might want to know what is 20% of 85. And some cues here are of in mathematics generally means multiply. So this one right here would translate as 20% times 85. And to do that, now sometimes there are calculators with a percent button, and pretty much that percent button just divides by 100 for you. So this means 20 over 100 times 85. And then calculator is often useful. I like my Desmos scientific calculator, and this is a lot like the $10 calculator I bought at a store in town. And so I can just type my 20 divided by 100, use the arrows to maneuver, times 85, and I get 17. Now notice there is a percent button here, so I could go 20% of 85. And so there are some calculators that have that percent button feature. And so maybe your scientific calculator does. And Desmos is a very nice one. So if you have classrooms with Chromebooks or tablets, Desmos is a free app that you could use in your classroom. So in this case, when we ask our calculator about this, we get the answer of 17. Now, sometimes those percent problems come in other forms. So I might get something like 17 is what percent of 85? And there's a couple of ways to look at this. One is similar to what I did here. Notice I have the word is here and I have an equals there with the 17. So is an equals. So translating this, I could say 17 equals what percent of 85? And to figure out what percent that is, I can just divide by 85, right? I have a multiply on this side. So if I divide both sides by 85 here, that ratio right there should be the decimal version of the percent that I want. Let's give it a try. So that should look familiar. 17 divided by 85. Okay, now what we're getting here is the number version of what I'm working with, 0.2. And so what I want to know is, if I rewrite this over here, 0.2 is what as a percentage. Now, percentage, again, remember that means divide by 100. So this symbol right here implies there's a division by 100 here. Well, let's think about that. This is 2/10, right? And if I multiply top and bottom by 10, I get 20 hundredths. And I have a divide by 100 there and a divide by 100 there. So that tells me that the number I want has to be 20. Now, with that in mind, let's think about an idea we had earlier, that the percent symbol literally means to divide by 100. Whether you write divide by 100 like that, or with a slash, or with a fraction bar, doesn't really matter. So when I see something like 20%, I know to translate that to a regular number, I take whatever number I was given to the left of the symbol and divide it by 100, and then go from there. Leave it as a fraction, make it a decimal. So to convert here a percent to a regular number, we divide by 100. If I want to go the other way and I want to convert a number like 0.2 to some percentage, then instead of dividing by 100, I should multiply by 100. And it's even better than that because we're actually multiplying by 100%. I'll explain why. So to convert a number to a percent, we multiply by 100. So if I take my number 0.2 and I multiply it by 100%, and remember, what is 100% as a number? Well, that's 100 over 100, which is 1. So technically, when I multiply by 100%, I'm multiplying by 1, which really doesn't change the value. However, if I clean up that multiplication and leave the symbol hanging, 100 times 2/10 is 20. And so I get 20%. That's kind of messy percent there. Let's try that in another number we saw before. If I start off with a number like 0.004, and I want to know what is that as a percent, then to make that calculation, I just take my 0.004, which is 4 thousandths really, and I multiply it by 100%. Clean up that part of the multiplication. Multiplying by 100 shifts the decimal point twice, so this should be 4/10 of a percent. So again, here I converted a number to a percent by multiplying by 100%. To convert a percent to a regular number, we just divide by 100. All right, let's play a little bit more. One common place we see percentages are sales. Like we might see a sale for 40% off. So I'm in the market for some new pedals for my mountain bike. And I found that there's a 40% off sale. And the pedals I want are really nice. They're aluminum with little screws on top to hold my feet still when I'm bouncing around on the trail. And regularly, the regular price for the pedals I want is $120. I want to know what the sale price is. So one way to go about doing that would be to find 40% of 120. So I could do this in a step-by-step process. 40% of $120 means to take 40% as a regular number, which could be written as 0.4, and multiply that by the 120. And we could whip out our calculator for that too. So 40 out of 100 times my $120 pedal means I should get $48 off. And so then the second step would be to take that $120 and subtract that $48 and see what we get. Without a calculator, we got to do a little borrowing here. So borrow from there, and then 11, take 4 away, gives us what, 7. So we get $72. Let's double check on the calculator, make sure it's a good day. And a lot of calculators have a previous answer button. It's good to teach your students how to use that. So I'm going to take my $120 and I'm going to subtract the previous answer, so I don't have to worry about typing it. And there's my 72. So I'm doing good math today so far. So that means I just found out that I pay $72 for those pedals. That's a lot better than 120. Still a lot of money though. Now I want to look at this in a slightly different way. The item I want to buy, its regular price, that's the idea of 100%. So I'm going to use that linear model to look at this for a moment. So let's draw out our linear model, choose green for money. So we'll start here and go out 10, 20, 30, 40, 50, 60, 70, 80, 90, there's 100. So here's my linear model getting set up there. And usually I mark it off right away. So at the beginning, I have 0, and at the end, I have 100%. Now, instead of using the decimal version of these underneath, I'm just going to leave them as percents in the top. I'm going to switch to money down below. And the regular price, that is the 100%. So down below here, I'm going to label this same endpoint as $120. Now I want 40% off. So from the 100, I want to go back 10, 20, 30, 40%. So this right here is going to represent my 40% off. So that puts me here on my drawing. Now, if I take 40% off, wouldn't you agree that that would leave 60% behind? So this chunk right here has to be 60%. So this picture tells me a bunch of different things. One, it tells me, well, instead of worrying about 40%, I just want to know what I pay. I don't really care how much I get off. Just tell me what to pay. So if there's 40% off, 100% is always the starting price minus the sale of 40%. That means you pay 60%. So I can do the subtraction up front instead of later on. And now I can find out the price of anything on a 40% off sale by just taking 60% of whatever I see. So in this case, what's 60% of 120? And I know 6 times 12 is 72, so that sounds like it's probably my answer. Now, there's another way to play around with this also. My picture, my linear model here, I drew specifically to have 10 chunks, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 squares there. Each of those squares is worth 10%. However, I could split those squares up into money. If there's $120 total and there's 10 squares there, 120 over 10 is pretty easy to calculate. That's 12. So each of these squares here, like this one in particular, is worth $12. How many squares are there? Well, there's 1, 2, 3, 4, 5, 6 of them. 6 times 12 is 72. So we can use the picture to figure out what the result is without having to do, say, the 40% off and then the subtraction. So there's a lot of different ways we can approach a problem like this. And not only can I use it for sales, but sometimes we have to mark things up in price. Like some jobs, you get a raise. When you buy something, if you're a store owner, you mark it up from what you paid to sell it. So let's look at one of those problems next. So this is called percent markup. And some stores have a fixed markup. Some stores, it depends on the item. Like you think about the dollar store for a minute, right? They sell everything for $1. Some stuff got marked up a lot. Like maybe it only cost them 10 cents. They sell it to you for $1. But other things might have cost 95 cents and they're selling it to you for $1, right? So those are two totally different markups. So with a percent markup, we just assume that a particular item or items always have the same markup. So let's say our percent markup is, let's try a 50% markup. So that means I'm increasing the price by 50%. So starting off with 100%, right? In business, that would be, say, your wholesale cost. And then we add on our markup. So I'm adding on to that the 50%, and combined, this is going to give me 150% of whatever I started with, and that's my selling price. So we could draw a linear model to go with that. So here is my 100%. And I made a little mark at 50 there, just in case I miscounted. And then we want to extend that another 10, 20, 30, 40, 50. So out here would be 150%. Now, the easy thing is if I know what the wholesale cost was to figure out what the selling price is. Okay, so some examples of this. If we have a cost of $70, what is the selling price? And we could use our picture here to figure that out. Or we could just use the idea of 150%, right? The selling price is always going to be 150% of wholesale price because the wholesale price represents 100%. So one way to solve this, if you just recognize that, would be to take that $70 and multiply it by 150%. So let's go whip out a calculator and see what we get. And maybe you're seeing that answer before we even calculate. And that's one reason we do the pictures, right? We want people to envision what the result could be. So I have my $70 and I want to multiply that by 150, and I could click the percent button, or I could just go divide by 100. And I think this one's designed to do the percent first. So I get 105, double check. If I take 150% of $70, it tells me again, 105. So we got the kind of straightforward calculator version. If we start with the cost and want to know the selling price, let's look at the picture version of that. So I'm just going to draw in 100% is my cost, right? Cost is 100% when I'm talking about markup. And so that $70 goes right here. So there's $70. Now, if it's 70 all the way to get to 100 and I have 10 equal chunks, that means each of these chunks must be worth $7. So that one's worth 7 and that one's worth 7 and that one's worth 7. I just have a whole bunch of 7s here. So this is one way kids could go about solving it. They could just throw a whole bunch of 7s in here and figure out how many there are. And here I see there's 5, 10, 15 7s. And if we double check on our calculator and we ask, hey, what is 15 times 7? We're going to see it's 105. Other kids will think, oh, 50% more. Well, 50% right here is half of 70, which is 35. So we just need to add another 35. There's so many cool ways of looking at this when you start drawing it out. If you add 35 to 70, you get that same 105 here. Now, what I want to look at is the other way. What if instead we see something with a price tag on the shelf and we want to figure out, oh, how much was that in wholesale cost? So let's look at this backwards and see what happens. So we're still doing percent markup. But we're going to do it in reverse. Suppose we know that the selling price is, let's see, how about $120? What is the wholesale cost? And what I'd encourage you to do here is draw a picture of this like I did here and realize that instead of knowing the cost, I know the selling price and I got to somehow work backwards. So take a sec to start drawing that. Think about it. I'm going to start my drawing too. And by the way, we're going to stick for the moment with our 50% markup. We can look at other ones in a moment. So we're going to stick with the same theme as the previous one, but this time, here would be my 100%. I drew out 10 squares to get there. I'm marking it up 50%, so this is my 150% there. And this time I'm given the selling price, which is the same as my 150%. So 150% is the same as $120. Can we then backtrack and figure out what is that wholesale cost? And there's many ways to look at this. All right, so we got an answer there. So let's try and figure this out. Let's see. So the 150, like the 100, is made out of a bunch of these squares. So there are 10 squares up to 100. There would be 15 squares up to 150. So this 120 is made up of 15 squares. So if I take my 120 and I divide by 15, that's going to tell me how much a square is worth. So let's try that on a calculator, and then I'll show a couple other ways. So I had 120, splitting that into 15 pieces, I get each square is $8. Good job. So every one of these squares is worth 8 if I have 150% total, which is also the same as $120. So we could draw in all of those 8s. So I have a whole bunch of 8s here. And how many 8s do I get to there? Well, there's 10 8s to get to 100% here. And so this must be $80 right there. Another thing this picture tells me is this picture shows me a proportion. And I'm going to view the proportion from the bottom up. So I want to know what that missing number is. And so what I'm going to do is I'm going to write question mark over 100, right? I'm going to group those two together, equals 120 over 150. Right, see where I'm getting at? Question mark over 100, 120 over 150. And if I solve this proportion by cross multiplying and dividing, or just multiplying that 100 up, I'm going to get the question mark is 120 times 100 over 150. And I could simplify that by playing with fractions, or I could just whip out my calculator. So again, 120 times 100 divided by 150, there's the 80 that we found the other way. And there's a ton of different ways you can look at this. Everybody's going to see this a little bit different because, right, we all have different things in our head, backgrounds, experiences. That gives me the 80 right there. Now, again, what's the point here? The point is that this linear model is really powerful. It can solve all kinds of problems. It helps you stop and think about how the numbers work together. But it's easy to mess this kind of thing up and do some accidentally bad math. So for example, let's look at an accidental way somebody might do this that's not going to yield the right answer. Now, normally when somebody gives me a percentage, I just multiply. So we are in the habit of seeing a percent and wanting to multiply, but it doesn't always work that way. So let's take a look here. So somebody might see this and say, oh, 50% markup, I just need to multiply by 50%. So they might try this. So here's a little experiment with the idea that I see a percent, I think I need to multiply. So what happens if I take 50% and I multiply it by 120, I'm going to get 60. Now, I know that this is the selling price, so I need to subtract to get the wholesale cost. So then I say, oh, I just take my 120 and I subtract 60, and that tells me that the selling price should have been $60. Now, here's the problem with that. Why doesn't that work? Why not? Well, one, it's got a different answer than before. Well, maybe the 80's wrong. It looked pretty good in my picture. So let's check our experiment. So to check my experiment, I'm just going to reverse that. So if somebody tells me that their cost of something was $60 and I'm marking it up 50%, well, I would say, okay, if I mark that up 50% of 60, well, that's 30. If I add that 30 back onto the 60, I get 90, not 120. So, something's wrong. Okay, so here's what's wrong. The markup has to be multiplied by the cost, not the selling price. Since the cost is smaller than the selling price, that means if I accidentally multiply by the selling price, I'm going to get too big a number for the amount of markup. All right, so let's write this out another way. So again, picture is very powerful if I use it right, but I can accidentally apply percentages wrong. So here's just a slightly different way to look at it. I know that if I have a cost and I multiply that by the percent markup, I'm going to call that percent MU for markup, this gives me the amount of markup. And then I add that back onto the cost. And that right there gives me the selling price. I'm just going to call that price here. In the case we just played with, we were giving a selling price of $120, but we weren't given the cost. We were given the percent markup. So now I have cost times percent markup. That was 50%. I'm just going to call it 0.5 plus the cost equals 120. So here I can see that it's not 120 I multiply by 50%, it's the cost, which I'm missing, right? Now, mostly when we're working with our kids, we're not gonna do algebra like this, but here's the cool thing. The picture does that for me, right? The picture does algebra without doing algebra, and kids can pull that out of the picture, which is super powerful.